Did you know that a planet in our solar system is so light it could float in water? That is, if you could find a bathtub big enough to hold it. This isn't a trick question. It is a remarkable fact about a truly magnificent world. This world is Saturn. It is a gas giant, a colossal ball of gas and liquid. It is most famous for its stunning system of rings. These rings make Saturn one of the most beautiful and recognizable sights in our cosmic neighborhood. Why does this particular planet capture our imagination so completely, inspiring awe in astronomers and stargazers alike? Let's embark on a journey to this distant, wondrous place and uncover some of its most fascinating secrets. Saturn is the sixth planet from our Sun. It orbits far out in the colder regions of our solar system. It is the second largest planet, with only Jupiter being more massive. Imagine a world so vast that over 760 Earths could comfortably fit inside it. Yet, despite its enormous size, Saturn is incredibly light for its volume. It is the least dense planet in our solar system. Its average density is less than that of water. This unique characteristic sets it apart from all other planets. Its low density is a significant clue to its composition, which is primarily hydrogen and helium, the lightest and most abundant elements in the entire universe. This makes Saturn a fascinating subject for scientists. The most striking feature of Saturn, the one that makes it instantly identifiable, is undoubtedly its spectacular system of rings. These are not solid, continuous bands as they might appear from Earth. Instead, they are composed of countless individual particles of ice and rock. These particles range in size from tiny microscopic dust grains to enormous chunks as large as mountains. They all orbit Saturn in a flat, incredibly thin disc-like structure. When we observe Saturn through a telescope, these rings present a breathtaking spectacle of light, shadow, and intricate detail. They reflect sunlight brilliantly, making Saturn shine brightly in our night sky, a true jewel. But Saturn is so much more than just its beautiful rings. It is a complex and dynamic world. It possesses a turbulent atmosphere with powerful storms, some larger than Earth. It also has a large and diverse family of moons, each a unique world in its own right. Some of these moons are icy spheres, while others harbor intriguing features like subsurface oceans. One moon, Titan, even has a thick atmosphere, somewhat similar to what Earth's atmosphere might have been like billions of years ago. Exploring Saturn and its intricate system is like opening a cosmic treasure chest, filled with scientific wonders and profound mysteries that continue to challenge our understanding. When you gaze at Saturn, even from the vast distance of Earth, its appearance is undeniably majestic. To the naked eye, it usually looks like a bright yellowish-white point of light steadily shining among the stars. However, with even a small telescope, its true glory begins to reveal itself. You can start to discern the iconic rings appearing almost like delicate handles on either side of the planet's disk. The planet itself is not perfectly spherical. Because it spins incredibly fast on its axis, Saturn is noticeably flattened at its poles and bulges out around its equator. This distinctive shape is known as an oblate spheroid. It tells us a lot about the planet's rapid rotation. Saturn's rapid spin is quite remarkable for such a large body. A day on Saturn, which is the time it takes for one full rotation, lasts only about 10.7 Earth hours. This swift rotation not only contributes to its flattened shape, but also plays a significant role in its atmospheric dynamics. It drives extremely strong winds and helps to create the distinct cloud bands that we observe. The planet's overall color is a pale yellow, often with subtle bands of beige, white, and sometimes even a hint of gold. These colors originate from the chemical composition of its upper atmosphere, which includes ammonia ice crystals, ammonium hydrosulfide crystals, and water ice crystals at different depths. Structurally, Saturn is classified as a gas giant. This means it doesn't have a solid, defined surface like Earth or Mars. If you were to try and land a spacecraft on Saturn, it wouldn't find any ground to touch down on. Instead, it would just sink deeper and deeper into its increasingly dense atmosphere. The pressure and temperature would rise dramatically as it descended towards the planet's interior. Scientists believe that Saturn has a small, hot, dense core made of rock and ice at its very center. This core is thought to be roughly the size of Earth, but significantly more massive, compressed by the immense weight above it. Surrounding this central core is a vast layer of metallic hydrogen. This is a very strange form of hydrogen that behaves like a liquid metal. It only exists under the extreme pressures found deep within gas giants like Saturn and Jupiter. Above this metallic hydrogen layer is an even larger ocean of liquid molecular hydrogen and helium. This then gradually transitions into the gaseous atmosphere that we can observe from afar. The immense pressure deep within Saturn is what transforms ordinary hydrogen into this electrically conductive metallic state. This layer is crucial because the movement and convection within the metallic hydrogen are believed to generate Saturn's powerful magnetic field. Saturn's rings are undoubtedly its most famous and visually stunning feature, a truly breathtaking sight in our solar system. They are not solid structures, as they might appear when viewed from a great distance with limited resolution. Instead, they are made up of billions upon billions, perhaps even trillions of individual particles. These particles are predominantly composed of water ice, making them highly reflective. However, they also contain a smaller fraction of rocky material and dust, which can influence their color and brightness. The sizes of these ring particles vary enormously, creating a diverse mix within the ring system. Some are as small as grains of fine sand or sugar. The rings are incredibly thin when you consider their vast horizontal extent. While the main rings stretch out up to 282,000 kilometers, which is about 175,000 miles, from the planet's equator, their vertical thickness is typically only about 10 meters, around 30 feet in most places. There are some regions where they might be a bit thicker, perhaps a few kilometers, but overall they are proportionally thinner than a sheet of paper. Imagine a sheet of paper the size of a large sports stadium. That gives you some idea of their remarkable proportions. This extreme thinness is quite astonishing and a key characteristic of the ring system we observe today. The rings are not just one single continuous band, they are meticulously divided into several main sections with noticeable gaps between them. Astronomers have given names to these divisions and the rings themselves. The most prominent gap is known as the Cassini division, a dark band approximately 4,800 kilometers, 3,000 miles wide, that separates the A ring, the outermost of the bright rings, from the B ring, the brightest and widest ring. These divisions and the overall intricate structure of the rings are primarily caused by the complex gravitational influences of Saturn's many moons, particularly the smaller ones that orbit near or even within the rings. The origin of Saturn's magnificent rings is still a topic of active scientific debate and research. One leading theory suggests that they are the remnants of a celestial body, perhaps a comet, an asteroid, or even one of Saturn's own moons that strayed too close to the giant planet. Saturn's powerful gravitational forces, its tidal forces, would have torn such a body apart into countless pieces. This debris then gradually spread out into orbit around Saturn, forming the flat disk of particles we see today. Another theory proposes that the rings might be leftover material from the very formation of Saturn and its moons billions of years ago, material that never coalesced into a larger body. The sheer beauty of Saturn's rings is truly captivating, a celestial ballet of light, ice, and gravity played out on an immense scale. The individual ice particles that make up the vast majority of the ring material act like countless tiny mirrors. They reflect sunlight back towards us here on Earth, and also towards any spacecraft visiting the system. This is the primary reason why the rings appear so bright and luminous even when viewed from millions of kilometers away. The brightness is not uniform across the entire ring system, however. Some parts of the rings are densely packed with these icy particles and consequently shine with a brilliant intensity. Other regions within the ring system are more sparsely populated with particles. These areas appear fainter and more translucent, almost ghostly in comparison to the brighter sections. This variation in particle density and distribution creates a stunning visual texture across the rings. When viewed up close by missions like Cassini, these textures resolve into an incredible array of subtle details, patterns, and structures. The rings also display a wonderful, though often subtle, palette of colours. They can range from brilliant, almost pure white and soft yellowish hues to more muted browns, delicate pinks, or even faint greys in some areas, hinting at their composition. These subtle colour variations observed across the rings are thought to be due to impurities mixed in with the dominant water ice. Over vast timescales, the pristine ice particles are constantly bombarded by micrometeoroids, tiny dust particles travelling through space. They are also continuously exposed to ultraviolet radiation from the Sun and charged particles trapped in Saturn's magnetosphere. This constant space weathering can cause chemical changes on the surfaces of the ice particles or coat them with a thin layer of darker, often carbon-rich material. This process gradually alters their reflectivity and colour, leading to the different shades we observe. The intricate structures found within the rings further add to their mesmerizing beauty and scientific interest. Features such as spokes were one of the surprising discoveries made by the Voyager spacecraft in the early 1980s. These are transient dark or bright radial features that appear to rotate with the rings, almost like the spokes on a giant ethereal wheel. They are thought to be caused by tiny, electrostatically charged dust particles levitating slightly above or below the main ring plane, perhaps influenced by Saturn's magnetic field. There are also delicate spiral waves and ripples created by the gravitational pull of nearby moons, revealing the rings as a dynamic system. Section 5. Titan, a moon like no other. Saturn is not alone in its journey through space. It possesses a large and fascinating family of moons. Over 140 moons have been officially recognized and named, and astronomers continue to discover more smaller moonlets orbiting the ringed giant. Among this extensive collection of natural satellites, one moon, Titan, stands out as truly exceptional and unique in our solar system. Titan is Saturn's largest moon by a significant margin, and it holds the distinction of being the second largest moon in the entire solar system, surpassed only by Jupiter's Ganymede. In fact, Titan is even bigger than the planet Mercury, making it a planetary-scale body in its own right. What makes Titan so particularly fascinating to scientists and space enthusiasts alike is its remarkably thick atmosphere. It is the only moon in our solar system known to possess a dense and substantial atmosphere, much denser than Earth's atmosphere, in fact, about 50% more pressure at the surface. This atmosphere is composed primarily of nitrogen, just like Earth's. However, it also contains significant amounts of methane and smaller quantities of ethane and other hydrocarbons. These compounds play a crucial role in Titan's unique weather systems and surface features, creating a world that is strangely Earth-like in some ways, yet profoundly alien in others. Titan's thick atmosphere gives it a characteristic hazy orange appearance when viewed from space. This global haze layer is made up of complex organic molecules, often referred to as tholins. These molecules are formed high in Titan's upper atmosphere when sunlight, particularly ultraviolet radiation, and energetic particles from Saturn's magnetosphere interact with the methane and nitrogen present there. These newly formed organic compounds then slowly rain down onto Titan's surface, blanketing it in a layer of organic material. Scientists are incredibly interested in these atmospheric and surface processes because they might offer clues about the chemical conditions on early Earth before life arose. One of the most exciting and significant discoveries on Titan, made by the International Cassini-Huygens mission, was the unambiguous presence of stable bodies of liquid on its surface. However, this liquid is not water, as one might initially expect. Titan is incredibly cold, with average surface temperatures hovering around a frigid -179 degrees Celsius, which is -290 degrees Fahrenheit. At these extreme temperatures, water ice is as hard as rock and forms the bedrock of Titan's surface. Instead, Titan has vast lakes, meandering rivers, and even large seas composed of liquid methane and ethane, primarily concentrated near its polar regions where it's even colder. Section 6: Enceladus and beyond Saturn's icy worlds. While Titan is undoubtedly a superstar among Saturn's moons, the ringed planet hosts other incredibly interesting and scientifically valuable icy worlds. One of the most captivating of these is Enceladus. This relatively small moon, measuring only about 500 kilometers or approximately 310 miles in diameter, has surprised and delighted scientists with its unexpected level of geological activity. Enceladus is one of the brightest objects in our entire solar system because its surface is covered in fresh, clean water ice. This pristine ice reflects almost all the sunlight that strikes it, giving it a brilliant white appearance and suggesting ongoing geological processes. The most astounding and groundbreaking discovery about Enceladus came from instruments aboard the Cassini spacecraft. During several daring flybys, Cassini flew directly through enormous plumes of water ice particles and water vapor erupting from long linear cracks near the moon's south pole. These fissures are informally nicknamed tiger stripes due to their appearance. These impressive geysers shoot material hundreds of kilometers out into space, far above Enceladus's surface. Detailed analysis of the material within these plumes revealed not just water, but also significant amounts of organic compounds, salts like sodium chloride and tiny silica nanoparticles, which are indicative of hydrothermal activity. The confirmed presence of a global subsurface ocean of liquid salt water combined with a potential energy source from hydrothermal vents on the sea floor, where the ocean meets the moon's rocky core, and the necessary chemical ingredients for life, including organic molecules, makes Enceladus one of the most promising places in our solar system to search for extraterrestrial life. It ticks many of the crucial boxes for habitability as we currently understand it. The material continuously erupting from its plumes actually forms and replenishes Saturn's E-ring, a faint, diffuse ring primarily composed of tiny ice particles that originated from Enceladus itself. Beyond the remarkable Titan and the active Enceladus, Saturn has a diverse and intriguing collection of other moons, each with its own story. Mimas is particularly famous for its enormous impact crater, named Herschel, which is so large relative to the moon's size that it makes Mimas look strikingly similar to the Death Star space station from the Star Wars films. Iapetus is a strange, two-toned moon, with one hemisphere as bright as freshly fallen snow and the other as dark as coal or asphalt. Rhea is a heavily cratered, ancient icy body, while Hyperion is a bizarre, irregularly shaped, sponge-like moon with a chaotic, unpredictable rotation. Section 7. Winds and storms inside Saturn's atmosphere. Saturn's atmosphere is a remarkably dynamic and turbulent place, a vast ocean of gases characterized by incredibly fast winds and colossal storm systems that can dwarf anything seen on Earth. The visible surface of Saturn that we observe through telescopes is actually the top of its highest cloud layers. These clouds are primarily composed of ammonia ice crystals, with other compounds like ammonium hydrosulfide and water ice forming deeper cloud layers below. These clouds are arranged in distinct bands that run parallel to the planet's equator, similar in appearance to Jupiter's famous belts and zones, but with generally more subtle colors and less contrast. The winds on Saturn are among the fastest ever recorded in our solar system. Near the planet's equator, these winds can reach astonishing speeds of up to 1,800 kilometers per hour, which is approximately 1,100 miles per hour. To put that into perspective, that is more than 4 times faster than the strongest hurricane-force winds ever measured on Earth. These incredibly powerful winds are primarily driven by 2 main factors: heat rising from Saturn's deep interior, a remnant from its formation, and the planet's very rapid rotation on its axis, which generates strong Coriolis forces that influence atmospheric circulation patterns. Periodically, enormous storm systems, sometimes referred to by astronomers as great white spots, erupt in Saturn's atmosphere. These storms are truly gigantic, far larger than any terrestrial storm, and can grow to encircle the entire planet, creating a bright, turbulent band visible even from Earth. They typically appear in Saturn's northern hemisphere approximately every 30 Earth years. This timing roughly corresponds to one Saturnian year, suggesting they are linked to seasonal changes, particularly during the northern hemisphere's summer, when that part of the planet receives more sunlight. Scientists believe these massive storms are caused by moist convection deep within Saturn's atmosphere. One particularly fascinating and enigmatic feature observed in Saturn's atmosphere is the persistent hexagonal cloud pattern located at its north pole. This is an enormous six-sided jet stream, with each side of the hexagon being wider than the diameter of Earth. It's a remarkably stable and long-lived weather system, rotating with the planet at roughly the same rate as its interior. Scientists are still working diligently to fully understand precisely how such a regular and complex geometric shape can form and persist for decades, possibly even centuries, in a fluid, gaseous atmosphere. Section 8. Voyagers and Cassini unveiling Saturn's secrets. Our modern understanding of the magnificent planet Saturn and its complex system has been profoundly shaped and revolutionized by robotic space missions sent from Earth. Before these intrepid explorers ventured into the outer solar system, Saturn was largely a distant mystery, a beautiful point of light with faint rings glimpsed through the lenses of ground-based telescopes. The first spacecraft to visit Saturn were NASA's Pioneer 11, which flew past in 1979, followed closely by Voyager 1 in 1980, and then Voyager 2 in 1981. These pioneering flyby missions provided humanity with its first close-up images and a wealth of scientific data about Saturn. The Voyager encounters, though relatively brief as they sped past the planet, were incredibly productive. They revealed stunning, intricate details within Saturn's ring system, including braids, kinks, and the mysterious spokes. They also discovered several new small moons orbiting the planet, adding to its known family of satellites. Furthermore, the Voyagers conducted detailed studies of Saturn's atmosphere, its powerful magnetic field, and its interaction with the solar wind. They truly opened our eyes to the incredible complexity and beauty of the Saturnian system, transforming it from a distant object of curiosity into a tangible, dynamic world that begged for further exploration. The groundbreaking observations made by the Voyager spacecraft laid the essential groundwork and provided the scientific impetus for a much more ambitious and dedicated mission, the Cassini-Huygens spacecraft. This was a major international collaboration between NASA, the European Space Agency, and the Italian Space Agency. Launched from Earth in 1997, the Cassini orbiter, carrying the Huygens probe, embarked on a 7-year journey to the ringed planet. It successfully entered orbit around Saturn in July 2004, and then spent an incredible 13 years meticulously studying the planet, its rings, its diverse moons, and its vast magnetosphere, in unprecedented detail. One of Cassini's most significant and celebrated achievements was the successful delivery of ESA's Huygens probe to the surface of Saturn's largest moon, Titan, in January 2005. This was the first and so far only landing ever accomplished in the outer solar system, a remarkable feat of engineering and navigation. Huygens provided groundbreaking data and stunning images from Titan's thick, hazy atmosphere and its surprisingly Earth-like though frigid surface, revealing methane lakes, river channels, and icy rocks. Cassini itself made numerous close flybys of many of Saturn's other moons, discovering Enceladus's active plumes and providing invaluable insights. The Cassini mission ended its historic journey in September 2017. Section 9. An Enduring Enigma, Why Saturn Captivates Us. Saturn, with its truly magnificent and iconic rings and its diverse and intriguing family of moons, continues to captivate the imaginations of both scientists and the general public around the globe. It is a planet of superlatives and unique characteristics. It is the second largest planet in our solar system, yet it is the only one with a density so low that it could theoretically float in water. It is home to some of the fastest winds ever measured, and it is adorned with the most spectacular and extensive ring system known to exist around any planet. Its sheer, undeniable beauty is a constant source of awe and wonder. From a purely scientific perspective, Saturn and its entire system serve as an invaluable natural laboratory for understanding the complex processes of planetary formation and evolution over cosmic timescales. Studying its predominantly hydrogen and helium composition, its dynamic atmosphere, its internal structure, and its powerful magnetic field helps us to piece together the puzzle of how gas giant planets form and how they change over billions of years. Its intricate rings offer unparalleled insights into orbital dynamics, the behavior of countless interacting particles, and potentially the ultimate fate of celestial bodies, like comets or moons, that venture too close to a massive gravitational influence. The moons of Saturn, particularly the enigmatic Titan and the surprisingly active Enceladus, have completely revolutionized our thinking about where life, or at least habitable conditions, might exist beyond our home planet, Earth. Titan, with its thick, organic, rich nitrogen-methane atmosphere and its surface seas of liquid hydrocarbons, presents an environment that is utterly alien, yet strangely familiar in its geological processes. It challenges our very definitions of what constitutes a habitable environment. Enceladus, with its confirmed subsurface saltwater ocean and evidence of hydrothermal activity on its seafloor, offers the tantalizing possibility of a habitable zone much closer to what we understand on Earth. Ultimately, Saturn serves as a profound reminder of the sheer vastness, the incredible diversity, and the breathtaking beauty of the cosmos that surrounds us. It vividly demonstrates that our solar system is filled with worlds that are incredibly different from our own, yet all governed by the same fundamental physical laws that operate throughout the universe. Exploring Saturn and its domain pushes the boundaries of our technological capabilities and expands the frontiers of our scientific knowledge. It encourages us to ask the big fundamental questions about our place in the universe, the potential for other worlds to harbor unique environments, and perhaps, one day, the discovery of life elsewhere.